So Unit 9 review number 2, I'm going to look at numbers 2 through 5. Starting with number 2 here. Number 2 says, a survey of 600 students from a local high school produced the following data. They were asked if their favorite book is Game of Thrones, The Hunger Games, or Lord of the Rings. And there's the table with some parts that are not filled out. And part A asks us to fill in the missing information. So we'll look at each one here for the Game of Thrones, freshman. That isn't filled out yet, so we know that these three have to add up to 200, so we're adding 60 and 66. Subtracting from 200, we should get 74 there. Same thing for the Hunger Games, add 74 and 42. Subtract from 200, we should get 84 there. For the Lord of the Rings, adding 82 and 38. Subtracting from 200, you should get 80. Then the last ones are the totals underneath freshmen and juniors. So for freshmen, we're adding 74, 74, and 82. That's 0, 1, 8, 15, 2, 30. Yeah. And then for juniors, adding 66, 42, and 80. 6 plus 2 is 8, 10, 18. Then, just to make sure everything is correct, we know that the total should combine up to make 600. So these three should add up to 600 if we did this right. 230 plus 182 plus 188. And that does, these three do add up to 600. So we've done part A, filling in the table. Part B, one of the 600 students is going to be randomly chosen for a follow-up questionnaire. What is the probability that the student will be a sophomore or a junior whose favorite book is The Hunger Games? So if we look at the Hunger Games, notice when they say the favorite book is the Hunger Games, that means we are only looking at this section of the table. Now it is saying or, it is an or probability. So what we're going to do is we're going to find first the probability that we have a sophomore plus the probability of having a junior plus, or sorry, subtract the overlap. In other words, people who are both sophomores and juniors. That's the or probability equation. So probability of the sophomore would be, for Hunger Games, 84 out of 200. Plus the juniors would be 42 out of 200 minus 0, because there isn't a student that's both a sophomore and junior at the same time. So we add, we get 116 over 200, and then into the calculator, 116 divided by 200, and it comes out to exactly 0.58, which means our probability is exactly 58% for number 2, or for part B. For part C, the juniors surveyed at the local high school are a representative sample of the community. If there are 3,000 total juniors in this community, how many of them would you expect to have Lord of the Rings as their favorite book? So we have 3,000 total juniors. Some portion of those 3,000 should like Lord of the Rings. Now, based on the table, when we look at the Lord of the Rings section, we're again talking about juniors. There are 80 juniors out of the 200 that like Lord of the Rings. So out of every 200 juniors, we have 80 that like Lord of the Rings. We have to find that portion of 3,000. In other words, we have to take 80 over 200 and multiply by 3,000. When we do that, 80 times 3,000, we get 240,000 over 200, cancel the zeros and the ends. So it becomes 2 into 2,400, which means we should have approximately 1,200 juniors. Oh wow, all that work. Oops, sorry. There's the work I was showing that you didn't see. We have 1,200 juniors that should have Lord of the Rings as their favorite book. Number 3, Mr. K. Hey, that's me. I am handing out blue and green Seahawks hats to his favorite students to celebrate the team's Super Bowl victory. He has 18 blue hats and 6 green hats. Part A, what is the probability that the first hat he passes out is blue? The blue hats, on top is the event. The total on the bottom is all the hats added together, which is 24. Which reduces, you don't always have to reduce, you won't On the test, you won't need to for most problems. But if we do reduce, we got 3 over 4, which is a 75% chance. Part B, after he is given the first hat out, what is the probability that the second hat he hands out is green? Now, since they said after he has given out the first hat, that means that we only need one probability. Sometimes we have those two fractions that we have to multiply with the separate probabilities, but now we're just finding the single probability of that second hat. Now we've already given the first half out, which means our total is no longer 24. That means there's a missing hat. It means there should be 23. Now we're assuming that the first one was blue. So here we're saying let's find what the total for the green is. We haven't given any green out, so that's 6. So our probability is 6 over 23. It's just the single hat, so we don't have to multiply any probabilities. 6 divided by 23 gives us 0.261 rounded, which is 26.1%. C, after the second hat is given out, hat, what is the probability that the third hat he hands out is blue? So now we're down to 22 hats. So we're saying that both of these hats were given out. This first one was blue, this first one was green, or second one was green. It means we're back to blue. Now we've already given one of the blue hats out in this first part, which means instead of 18, we actually have 17 that are blue. So we have 17 out of 22, divide, get a decimal, it becomes 0.773, which is 77.3%. Number 4. 4 and 5 left in this video. There is a 10% chance the LA Kings beat the Chicago Blackhawks. If LA wins, there is an 80% chance Mr. Cam will shave his head. What is the probability that LA wins and Mr. Cam shaves his head? Now they're asking very specifically about the two probabilities they just gave. This is an AND version. Notice they put the AND, they highlight the AND there. And then AND version of probabilities, so we're taking the probability of LA times the probability of, let's put S for shave. So we're taking the LA Kings winning, which is 10% chance, which as a decimal is 0.1. And we're multiplying by Mr. Cam shaving his head, 80%, 0.8. When we multiply those, we get 0.08, which means we have an 8% chance of that happening. It's not going to happen. Number 5, last one in this video. Next year, Alfonso will either take AP Stats or Calculus. If he takes AP Stats, there's a 60% chance he passes the course. If he takes Calculus, there's a 30% chance he passes the course. This is one of those problems where we use a tree diagram. So in our tree diagram, we'd have AP Stats or Calculus. Now they didn't say this. These first two just represent Alfonso choosing to take one of the courses. This is, in other words, him choosing to take AP Stats or choosing to take Calculus. Then once that choice is made, he either passes or fails. Passes, fails. Now for AP Stats, again, if he takes AP, there's a 60% chance he passes the course. So our 0.6 would go in there. For the other course, Calculus, there's a 30% chance he passes. That's again after he's chosen to take the course. So that one's 0.3. Part A says if the actual probability Alfonso takes Calculus and passes is 24%, meaning he's chosen to take Calculus and then he passes is 24%. What is the probability he takes Calculus? Which means that what we're trying to find is this probability, this percentage, something times 0.3 to give us 0.24. Now, since we're working backwards, what we can do, you can either guess and check. You can just plug numbers in, or you can take that 0.24 at the end after he's taken it and passed it and divide it by the 0.3 chance of passing. When we do that, we get I think it's 8. Yeah, 0.24 divided by 0.3. 0.8, which is an 80% chance. So this calculus decision, just deciding to take calculus, is an 80% chance. Part B, what is the probability he takes AP Stats? So we just found out that he has an 8% chance of choosing calculus. And when he makes this first choice, he's only choosing between AP Stats and Calculus. He's just got two things he's choosing from, which means we can take that 80% from Calculus, subtract from 100% total. These two should add up to 100% to get our percentage for AP Stats, which is 20%. So that's 0.2. Part C. What is the total overall probability Alfonso passes his math course next year? So we have two ways for him to pass the course. Either he takes Calculus and passes it, which we already know is a 24% chance, or he takes AP Stats and passes it. And we don't know this yet, but since we now know that this is 0.2, or 20%, we can take 0.2 and multiply by 0.6 and get 0.12 as the probability of him taking AP and passing the course, which means for either course, he has these, again, two opportunities to pass, two ways he can pass the course. We're adding 12% plus 24% for the total overall probability that he would pass next year, which is 36%.